What is going on, everyone? This is Ippsec, and I hope you've been enjoying the Business CTF 2024 talks and are excited for the CTF this upcoming weekend. I know everyone at Hack the Box is super excited for you to play the challenges. A lot of work has gone into this, and I decided for my little 30 minutes I have here to talk to you today, I just help you prepare for the CTF by walking through one of the challenges that was put on last year's CTF, and that challenge was Watersnake. It is a web-based challenge and it's in the easy category. It has a deserialization vulnerability in it, which sounds a bit odd for being easy because normally those two don't get along. But let's just see exactly what this is about. For all the challenges, you'll generally get a target on the website, and that's just going to be like a IP and port. And then you'll also have a bunch of downloads, which is a zip file. Normally, Hack the Box is the password, and it just contains like the Docker file and all the web source code. So you could just start right off and look at the source code to try to find vulnerabilities, but I just can't visualize a website when I'm looking at the source. So my first step always is just to go take a look at the website to see what it looks like and what the source code is going to be showing. And this is Watersnake. We just see it looks like some water tank levels, nothing too interesting here. If I click on dashboard, that is the page I was at. If I click on firmware update, it shows we got some YAML and then a submit. So we can send YAML data here. If we just send like test one over to submit, it just says config queued for firmware update. So that's interesting. This is the first place we have to send data to the server. So since we can send data, this is probably going to be where I want to focus at when I look at the web source code. Then we also have this about page that just talks about what this application is. So we don't really have that much. I guess we could go blindly attacking this. We could fuzz it for other endpoints to see if there's something hidden, maybe like a login page or something like that. However, why go through all that and just run enumeration tools when we can go into the source code and look at it that way? So I'm going to go in where all the files are and do code dot. That's going to open up Visual Studio Code. And I have some extensions that really make just source code analysis easy, namely things like Sneak and things like that that automatically find vulnerabilities. So we can see Visual Studio is running. We have some analysis going. Java is activating. We can look at it. So I'm going to go to source, and then we can look at this application. It is going to be running Spring Boot. So we could look for like Spring Boot CVEs if we wanted to. Let's just hold on one second. So I have sticky notes on my monitor, so I don't put my mouse over the area. And I just realized because I had sticky notes there, I couldn't click the buttons. So hopefully my webcam doesn't get in the way too much. So let's see. We have application. Nothing's really shown here. If we go to controller, we have quite a bit. So we have slash, and that's going to give me the HTML for this page. We have slash stats. We haven't seen this. And it's going to read from sensor. It's going to execute dot slash water sensor and do stats. So let's go ahead and hit slash stats and see what happens. So go over here, hit slash stats, and we just get tank levels. If I refresh, it looks like the tank levels are going to be staying the same. So nothing too interesting there. There is slash update, and then that is doing a YAML load. So this is that YAML entry point. If we highlight over it, we see deserialization of untrusted data. So this whole is, this is going to be the update config. If we trace it back, this is going to be the user input. So this is where probably a vulnerability is. Sneak is telling us there is a deserialization of untrusted data. So we just have to figure out how to like exploit this, right? If we go up here, let's see, do we see anything? I'm going to guess it's going to use the Snake YAML library to parse the YAML. So this is where I would go looking for any type of deserialization vulnerability, right? And before we just keep going down that train, there's only one file left, so I want to look at it to see exactly what this is doing. We have get water level, and then we have read from sensor. It's going to take in a string, and then it's going to do new process builder, splitting the string on spaces, and run it. So this is essentially just going to run like any shell command, essentially is what that's doing. Then we have initiate sensor, which is going to read from sensor, that function we just saw. And there's also the function this get water level, which is going to call initiate sensor. So this whole thing is just a gadget around running a process, right? The function of this class, the get water level, is going to initiate sensor, and initiate sensor is going to read from sensor, and read from sensor is going to call the shell command that we generate to read data, right? And we could go and find this in files. Do we have where it's actually used in this controller? Right here. So we do get water level right here, sensor reader, and we're passing in this water sensor dash dash init. So that again is a binary. I'm sure if we looked at the source code, we'd be able to find where the water sensor C code is. Let's see. We go target, no, maybe sensor.c. So this is the source code of the water sensor, right? And if you wanted to, you could also find all this out if by going to the Docker file and seeing how it's all built. Was that it? Yeah. Let's see. Sensor. There we go. It's doing gcc sensor.c to call it water sensor. So going back to this, we know if we can get some deserialization, there is a gadget here. We can call this get water level function to get code execution. Because if we're doing deserialization, we'll control what parameter gets sent to this get water level. Because everywhere else, it's just hard-coded strings like that / water sensor init stats. There's no user input here, so we can't get command injection. But if we call the function ourselves, we can. So that's why we want to exploit this YAML load to call that function. So the first place I'd be going is the pom.xml file, because this is going to be Spring Boot, a bunch of like Java things. I don't think it's just Spring Boot that uses pom, but I'd go here just to see where all the libraries are. We know it was Snake YAML, so this is going to tell us what version of Snake YAML it's using. And it's highlighted in red because there is a vulnerability with this. So we see Snake YAML at 1.33, and it has one vulnerability. It is critical, and this isn't giving me a link. So let's just go over to GitHub or Google to search. So we're going to search Snake YAML vulnerability 133. We'll go over to Google. And let's see, do we have anything good here? This is the GitHub page. They're talking about discussion there. So this is the details around it. See, CVE 2022. This looks like a good post to go with. I'm surprised Sneak didn't see it. If we go over to Sneak, we can see all the vulnerabilities it found. The open source security failed for some reason. This is what should be looking at the POM XML and finding it. So something's wrong with my setup here that just had Sneak not find it. But thankfully, I had that Red Hat Open Vulnerability Database plugin as well to be a second check just in case things like that happen, right? If we go to the code security, it is again highlighting the deserialization of trusted data. It doesn't give me examples of how to exploit it, so let's go read this blog post. It's a well-known parser. What does the vulnerability look like? This is going to be the code. It's just doing a YAML load input stream. Our code looks a little bit different just because we're taking the user input from HTTP parameters, but we do see it doing a YAML load there. So here they have a vulnerability demo. They have the class Gadget, and the function for Gadget is the string, and they're just running the command. So what they're doing here is they're going to put a double exclamation point, and then the class path, I think this is called, the function, and then the command. And the command goes in the square brackets to run. So that looks like all we have to do. Now, the issue is we don't have a way to get command output back, right? The easiest way would be just like having the server reach back to us and run a command, or like reach back to a web server. This is going to be a challenge, so we're not on the VPN, so we have to normally use tools like ngrok or local tunnel in order to stand up a endpoint on the internet so the box can reach us. So let's do that real quick. I'm going to, let's go here. I'm going to make a www directory. And then I'm just going to run python 3-m HTTP server. So I have a Python 3 web server running on port 8000. And I have ngrok installed. So we'll do ngrok HTTP and pass everything to HTTP 127.0.0.1 8000. Okay. So now if I go to this URL, it's going to send me to that Python server. I'm just going to test that real quick. You're about to visit. Visit site. That may actually be an issue. I've never seen that before. I'm surprised it made me click through. Okay. We're going to see if that becomes an issue. So let's go back over to this. We can go in here. And then what was the thing? We had to do 2 exclamation points. And man, that is still somewhat small. I'm going to send this over to Burp Suite because I think this will be a bit better, but I have to open up Burp. So we'll open it up and proxy it. Start. I don't need to update. Let's go. Where's the proxy window? View. There we go. Don't know where proxy ad went off to, but we got it back. Refresh this page. Okay. So if I do submit, maybe that's easy to read, maybe it's not. But okay, so we do the 2 exclamation points, and then we have to give it the class path. Let's see. Going to go up here, and it's going to be lean Watersnake. And then the get water level, right? And let's see. The first thing I'm going to try is I'm going to do a sleep 1 real quick. I wonder if I encode that or not. So we got a response time of 1.1 millisecond. If I do sleep 2, hopefully this is 2 milliseconds. It is. So that confirms we have code execution. Then we could also do a curl. So we can do curl. And let's see. We want to go to this URL. Like that. I'm going to do /test real quick. If we send this, do we have a hit? We do. So the server has made a request to us. So what we want to do here is send a file. So to do that, let's see. I'm trying to think the best way. Because if we open up a new pane, we know there's a flag.txt. If I look at Docker file, we see it's just going to be at the root. So we want to grab /flag.txt. I wonder if we could go back here. Can we just cat flag.txt like this? I don't know if that's going to work. We'll find out. Run that. Let's see. It stopped after the space, so I'll encode it. That did not work. So what we can do is tell our curl request to grab a file. So I think that's the -d flag, and then @/flag.txt. Is that going to be it? NCLVNP 8000. And there we go. So all we did, the -d is going to say data, right? And then the @ says grab file. So we said, hey, data, grab the file and put it in a post, and we get the flag. But that's not going to be it. I mean, we're only like 14 minutes into this video. So let's go a little bit beyond just this. Let's think about for a second. What if the server couldn't reach back to us? What would I do there? Well, the first thing I do is probably build this Docker out. So I'm going to do bash build Docker, and I already have Docker installed on my local host. So it can run all this. So if you don't have Docker installed on your local host, obviously this is going to fail because it can't run the web serve. Like it can't run a Docker if you don't have Docker installed. So now that we have this, my goal here is I'm going to go into the container and I'm going to see where the web root is and see if I can just drop files there. Because instead of doing a curl to send it to me, I'm able to do a CP command to just CP the file on a web directory that I can access. That is a good way for bypassing a lot of the firewalls. And then after this, we're going to get a reverse shell on this. And we're not even going to use that get water level gadget. We're going to just magically inject our own gadget into the box. So that'll be a lot of fun, I think. So let's see. I think the web server is stood up. It runs on Leap by default. So if I do localhost 1337, we probably have to turn Firefox off. That is running. So I'm going to do a docker ps. We can do docker exec it 223a9 sh. So now I'm in this container. So I'm going to go cd/. If I do bash, there we go. I'm going to do find / name and what was one of the files. Index.html. I don't like using that one just because a lot of like applications may use it. It's like a super common web name. So I'm going to go with about.html. And we see it's in 3 places. We have it in the source, the target, and the build. I'm going to try the target first. I think it's actually the build one, but let's see what happens when we fail. I always like making errors and failing because whenever you fail, you learn what doesn't work, which is oddly super important, right? So now I can go to test.html. We have white label error space, so did not work. Let's go over to the build. So I'm going to copy this, go here, and then copy about test HTML, refresh. And that still did not work. I could have swore that one was. Let's see, about. Oh, I actually wrote copy. Did I do that before? No, I did not. I guess I was just talking while I was working. And there we go. We have test HTML here. So what this means is we can copy the flag to this location and then read it. So let's go back to our Burp Suite window. I'm going to go over to Repeater tab. Instead of this curl command, let's just do a CP command. Definitely not a copy command because that just doesn't work. I think Windows actually works on both, but apparently Linux does not. And let's go grab this path. And I'm going to call it flag.txt. So before we run this, let's validate flag.txt does not exist here. Okay. I'm going to send this. We'll refresh. And we got the flag. We didn't need the server to reach back to our server web. We could just copy it to a place we could write to. Now, let's go to the last piece really quick. If we looked at GitHub, I think artsploit is common on deserialization. So I'm just going to do artsploit GitHub. Let's see. There we go. This YAML payload library. So what this is going to do is it's actually going to create the gadget for us. If I didn't say it, these 2 exclamation points in YAML is data type. So what this is doing is saying, hey, the data type of this, which is an object, like in Python, if you wanted to define a string, it'd be like exclamation point string. So this just means data type. So we're going to go to the script manager, and then we're going to go inside the script manager and do the URL class loader, and then tell that one, hey, go to this URL and load a jar file, which is like a Java library. And that will just give us code execution because we're loading the library ourselves. We're going to have to do a little bit of funkiness because I don't want to deal with firewalls on our box, and Grok only has 1 connection at a time. I'm going to use a different service, so that'll be why we switch to that in a minute. But let's just clone this real quick and get a reverse shell, and I added an H there. So I'm going to go into YAML payload. We can do code dot, open up another Visual Studio Code. And when we go in source, our exploit, awesome script engine, let's trust all these folders. What can go wrong? We see it's just doing a dig and then running this calculator. I'm going to go to revshells.net. I think it's revshells.net and grab a Java reverse shell. Maybe it's .com. It is. So I'm going to be what? 1010. Oh, let's just leave that and we'll edit it. Let's go to Java. Where is Java? There we go. And let's see, we got to copy this. Go here. We will paste. And then we also have to create the process. There we go. Throws an exception that we did not handle. Quick fix. Add throws. Awesome. Okay. So this is doing the reverse shell payload we normally use. I think like a single quote is a bad character or something. So that's why it's doing this. This is just saying like every single argument and then this is a pipe. So it's just another way of saying like that, right? So, okay. Was it bash 0? Yep. Okay. Bash I. So here is where we're going to want to send our data. So let's go back to where grok is. And we want to send this to be a TCP connection. And then we'll send it to 9001. Let's see. I screwed something up. It's not TCP colon. There we go. And we can say NC LVMP 9001. Now, the issue we have right now is we have to be able to have a web server as well. And that's where I'm going to use local tunnel. If we Google local tunnel, I think that's all we have to do. It's going to be very similar to ngrok. So we just say LT port and then it sets up a web tunnel for us. So this is my way of getting around having a TCP and HTTP. I think local tunnel only supports web. So we do local tunnel port 8000, go to www, Python 3m, HTTP server. There we go. So this is going to be the URL of the web server, but this is the reverse shell. So we got that. And then this port is missing one character, I think, 17605. Okay. I think that's good. Hopefully the demo gods don't get me here. Let's see. If I cat the readme, he says how to run it. We just run these two Java commands. The first one is going to create the .java file, which is like the library. The second one's going to bundle it up into a jar. And there's no errors, so everything's looking good. I hope I didn't jinx myself there. I'm going to copy the YAML payload in www. I'm going to look at my web shell again. www is there. So let's go and grab this, and we're going to paste this in. So let's go back here. We could do it in Burp Suite. I'm just going to do it in this firmware update window because I hate like worrying about URL encoding. I'll let the browser handle it for me. So this payload, this is going to be the one where we use local tunnel. And it's rude signs guest.loca.lt. Cool domain. Let's get rid of this. And I'm going to try to have this so we can see the shells come, because that is going to be the exciting part. Because you're all going to see I made a stupid mistake and it failed, right? But we hit submit. We get the callback here. It did a get YAML payload, and we have a shell on the endpoint, right? So that is going to be Watersnake. How we could exploit it multiple ways. I'd always recommend whenever you do a challenge, go back and like remove something to see if you can still exploit it, right? Like I did. I was like, I wonder if like there was a firewall preventing the box from getting back to me. Could I still do this? Yes, I could go and just drop it on a like the web directory and then access it that way. And then I was like, I wonder if this whole YAML library, if there's any way we could just like invent our own gadget. And you do enough Google searching, you find other research that points you towards that direction that shows you the other ways, right? So, with that being said, I hope you enjoyed this. And yeah, enjoy the rest of Business CTF 2024. Take care, all.